Hello everyone, in the previous video we have seen what is fixed point iteration method. In this video we will try to code that same method in MATLAB. For that we will be given a question in which we have to find the real root of the equation, and the initial interval and the initial approximation is already given. So here we are given that f of x is equals to cos x minus 3x plus 1 equals to 0, and the value of a is given as 0 and the value of b is given as 1, and the initial approximation is given as 0. Firstly, we will rewrite the given equation f of x equals to 0. Let 3x is equals to cos x plus 1. From here the value of x be cos x plus 1 by 3, which will be my possible choice of g of x. Now we will check if this choice of g of x will help this iteration method to converge to its root or not. For that we will let g of x as cos x plus 1 by 3. Finding the derivative with respect to x, it becomes minus of sin x by 3. Taking mod both sides, the behavior of sin of x in the given interval. We know the graph of sin of x is like this in the interval 0, pi, where the highest value of sin of x is 1 at pi by 2. Taking the value of pi as 3.14, we know that pi by 2 is strictly greater than 1. So the value of x equals to 1 will be before pi by 2, and at that point, starting from 0 to 1, the value of sin of x is strictly less than 1. So we can say that g dash x is strictly less than 1 by 3, which is again less than 1. Therefore, this choice of g of x will work for this iteration method. Now quickly starting the MATLAB code, we will have the tolerance as 0.001, and we will take the g of x, which is manipulated function g of x from f of x as input from the user, and also we will take input of the initial guess from the user. Now all the necessary conditions to start the iterative process have been taken as input from the user. Now we have to perform the iterative process. For this we will use for loop starting from 1 with the increment of 1 till 100. Now we will use the iterative process as c is equals to g of d, where d will be my initial guess and will store that value in C. Using the printing statement, checking the stopping criteria, if the absolute value of C minus D is less than tolerance, then we will break this loop. Otherwise, we will update the value of D as C and continue this iteration till the stopping criteria is fulfilled. In the end, we will use the printing statement to print the total number of iterations as %d and the root of the equation as C. Now let us understand this loop first. Since we have entered the function g of x, and in the fixed point iterative method, the iterative process is like xn plus 1 is equals to g of xn, where the initial guess is already given as 0, which is x naught, and I have taken the value of x naught and stored in the variable d. Then I have started the iterative process. For the first iteration, I have calculated the value of g of x naught, which is equals to g of d, and stored in the variable c. Then I have checked the stopping criteria for x1 minus x naught, which is equals to c minus d. If this is less than tolerance, then we will break this loop. Otherwise, we will perform the second iteration. When we will perform the second iteration, I have updated the value of d as c. Now the value of x1 is c and x2 is equals to g of x1, which is equals to g of c. Since I have updated the value of d as c, so I can also use it as g of d. Then this calculated value is again stored in the variable c. Again we will check the stopping criteria, and in this way all the iterative process will continue till the stopping criteria is satisfied. This is very simple code of fixed point iteration method. Let us see what will be the output of this code when we will use this above mentioned question. After running this code, this will ask to enter the manipulated function g of x from f of x, which we will enter like this form. After entering the initial guess as 0, the iterative process will start and we will have the root as 0.607182, which is correct up to 4 decimal places. Now let us see when we will change the initial guess in this same question. After running the fixed point iteration method again, we have changed the initial guess as 0.3, and we have seen the root is similar up to 4 decimal places. So we have made an understanding that the root of this equation is 0.607 correct up to 3 decimal places. What if we took the initial guess as 0.7, which is more than the required root? After taking 0.7 as the initial guess, we have seen the root is still correct up to 3 decimal places. So from here we have made an understanding that we can take the initial guess as any number between the given interval. Now let us try to modify the code we have discussed. This is the code we have discussed. Now let us try to find the initial interval where the root will lie. For that, we will add some lines of codes after defining the tolerance. We will initially input the function whose root we need to find. After entering the function, we have to check where the intermediate value property will satisfy. For this, we will use for loop, and I am initializing the for loop from -10 with the increment of 1 till 10. You can always change this initial and terminal value of this for loop, provided if you know that one root of the given equation will definitely lie in this range. Using the printing statement, this will help you to show what is the value of the function at each point where the intermediate value property is satisfying or not. If the intermediate value property is satisfied between f of I plus 1, then we will print the root of the equation lies in the interval I and I plus 1. Then we will break this loop, otherwise we will perform these lines of codes for the next value of I. So with the help of these lines, we will know what is the initial interval where the root of the given equation will lie. The next part of the fixed point iteration method is that we have to find the manipulated function g of x and check if that g of x function will work for the iterative process or not. To check that, we used to derivate that function, find the mod of that function, and if the maximum value of that function is less than 1, then we say that this function will help the iterative process to converge to its roots, otherwise not. The code we have discussed before will not check if that function value will help the iterative process to converge to its roots or not. We have to manually check that process before entering that function into the MATLAB code. For that, we will add some lines of codes after we will ask the user to enter the manipulated function. Since we have to find the derivative of g of x, for that we will use symbolic x and then use the inbuilt function which helps us to find the differentiation of g with respect to x. Now we have to check if the maximum value of this absolute value of h is less than 1 for every point of the given interval or not. For that, we will use for loop starting from the value of I, because I is the initial point of the interval. Since we have to check the function value at every possible point between this interval, so consider the increment as low as possible. till I plus 1. Now check if the absolute value of h at every possible point j is less than equals to 1 or not. If this thing is satisfied, then we have no problem, else we will use a printing statement which says that equation will not converge in this interval for this choice of g of x. Then we will break, otherwise this loop will continue till the terminal point of the interval. So I hope you have made an understanding of this code. Let us do one more practice question which says to use the iteration method to find the root of the equation correct up to 3 decimal places. Since the initial interval is not given here, so we have to find the interval where the root of this equation will lie. We are given that f of x is equals to x cube plus x square minus 100 equals to 0. Let x is equals to 4 implies the function value at 4b 4 cube plus 4 square minus 100 equals to minus 20, which is negative, and for x is equals to 5 the function value at 5b 5 cube plus 5 square minus 100, which is equals to 50 and is positive. Since the intermediate value property is satisfied for the value of x equals to 4 and x equals to 5, so a real root of given equation lie between the interval 4 and 5. Now we will rewrite the given equation f of x equals to 0 as x cube plus x square on one side and taking 100 on another side, taking x square common, from here the value of x becomes plus minus under root of 100 divided by under root of x plus 1. Let g of x be 10 upon under root of x plus 1. To check if this function will help the fixed point iteration method to converge or not, we have to find its derivative with respect to x, which becomes 5 upon x plus 1 to the power 3 by 2. Taking mod both sides, this becomes 5 upon x plus 1 to the power 3 by 2 mod. Since the variable is in denominator, lower the value of x, higher will be the whole value. So we will use the value of x as 4, which is the minimum possible value in the interval 4, 5. and after solving this becomes 1 upon under root of 5, which is strictly less than 1. So the iterative process defined by xn plus 1 is equals to g of xn as 10 upon under root of 1 plus xn will converge to the root. Now we have the manipulated function g of x, the initial interval. The next we have to take is the initial approximation and let it be as 4.5. Now use all these values to input in the given MATLAB code we have discussed before and find its root up to the desired accuracy. Here are some practice questions for you. Firstly, solve these questions manually and check if you have done the iterative process correctly with the help of the MATLAB code we have discussed before. Compiling this lecture, initially we have used this question to make a MATLAB code in a very simple manner. I am repeating again, if you are to use this MATLAB code, you have to firstly verify if the function g of x you are taking here will converge for this iterative method or not. If you are not checking this function before inputting this to the MATLAB code, your MATLAB code may not give you the correct root of the given problem. After that, we have modified this same code where we have find the initial interval and checked if the manipulated function will work for this iterative process or not, and then we have started the iterative process. Then we have discussed a question. Hope you have made an understanding of this code, and if you still have any doubts, please let me know in the comment sections. Keep learning.